Hello everyone. Jawaharlal Nehru Planetarium, Bengaluru welcomes you to demonstrations in astronomy. Most of us think that all the planets are spherical in shape, but in reality they are actually not spherical, but they are geoidal in shape. What is this geoidal shape? It is a shape which is like flattened at the poles and bulged at the equator. All our planets are in this geoidal shape, and now with the help of this model we shall try to understand why the planets take this geoidal shape. Okay. So the model here has a circular strip. It's basically a metallic strip bent in the form of a circle, and this whole strip is mounted on a rotating platform, and the platform can be set into rotation. As you can see, there is a rod here, the central rod. This is the axis of rotation of this circular strip, and there is another rod here. There is another rod here. This is some kind of a equator for our planet. Now let us set this thing into rotation and see what happens. So as long as I rotated the whole thing, you could actually see that there is a small mark here which is as of now not visible, but when the thing was set into rotation, we could see that the strip had moved down like that here, which means it had got flattened here, and at the same time we could see that it has also bulged here at the equator. So it was flattened at the poles and bulged at the equators. So with this model we can actually see that when the strip was rotating, it actually got flattened at the poles and bulged at the equators. All our planets are rotating, and due to this rotation they are actually getting this geoidal shape. Basically all planets get their shape due to gravity, but it is the speed at which they are rotating which is a primary cause for this geoidal shape of the planets. Another thing that affects the geoidal shape of the planet or the oblateness of the planet is its composition. If we consider a hard, rocky planet like our Earth, and if we just observe the pole-to-pole diameter and the equatorial diameter, the difference is not much. In fact, the pole-to-pole diameter is only about 40 kilometers lesser than the equatorial diameter for our Earth. Whereas, if you consider planets like Jupiter, Saturn, which are gas giants and also rapid rotators, there we can actually observe a substantial difference between the pole-to-pole diameter and the equatorial diameter. On the other hand, if we consider very slow rotators like our Moon, the planet Venus, there this difference between the pole-to-pole diameter and the equatorial diameter is not that much. Okay? So this geoidal shape of the planets is basically affected by the speed of rotation and the composition of the planets. Thank you.